Okay, so welcome back once again, guys. Now, in this lecture, again, I'm going to talk about a couple of terms with respect to probability. So let's start talking about that. So first of all, I'll be talking about something called as sample space and event. So what is a meaning of a sample space and what is the meaning of an event? This is something which I'm going to talk about. And then I'll be talking about what is called as mutually exclusive and independent event. So first of all, here the very first term, again these are the terms which we generally try to use with respect to a probability. So what is called as a sample space? I'm just trying to give you a recap if you're not able to recall something from a childhood. So these lectures are going to work you with respect to recalling each and everything which you are going to utilize it while understanding the algorithm or while doing a practical. So here sample space and event. So what is called as sample space and what is called as event? I'll try to give you the understanding about this one. So if I'll talk about a sample space, so sample space, what definition says? It's a very easy one, right? All of you will be able to recall and understand. So let's suppose if I'm trying to represent it with S. So here sample space is nothing but all the possible outcome. That is called as sample space, just a term, right? And what is called as events, by the way? So events is nothing but a subset of sample space. That is called as basically events. Okay, fine. So let's suppose if I'm trying to flip a coin twice. If I'm going to flip a coin twice. So example. So I am flipping a coin twice. Now, what is going to be my sample space? Two times I'm trying to flip my coin. So here my sample space could be head, right? It could be head, tail. It could be tail, head, first time tail, second time head, and then here first time head, second time tail, and maybe a tail. So now this is the all kind of a possible outcome that I can receive if I'm trying to flip a coin, right? So this is basically called as sample space. This is basically called as sample space. Now what I can say in terms of an event. So let's suppose if I'm going to ask you a question that tell me all the events, basically tell me all the events of getting at least one head. So now what is going to my event, by the way? So I'm getting head here, I'm getting head here, I'm getting head here. So head, tail, and then tail, head. So this is going to be my event. Yeah, this is going to be my event basically. So here, right? So we are able to understand that what is the sample space. Sample space means all the possible outcome, as simple as that. And event means a subset of the sample space. So as you can see, this is nothing but a subset of the sample space which I have created over here, as simple as that. So hope all of you are able to understand that what is the meaning of a sample space and what is the meaning of a event. Now let's try to talk about another term. Again, it's term which I'm going to discuss, right? Because we all are going to use all of these terms frequently in our lectures as well as in our practical. So there is a term called as mutually exclusive. Mutually exclusive. Mutually exclusive and independent events. Now, what kind of a event is called as mutually exclusive, or what is the definition of this mutually exclusive or independent, or and I can say so, and independent event? So here, first of all, if I'm going to talk about mutually exclusive term, right? So it's called as, in other word, definition wise, you can say that event cannot occur simultaneously, and that is called as mutually exclusive event. An event cannot occur Simultaneously, it's called as, or it's labeled as, basically a mutually exclusive event. I'll try to give you an example of that so that you all will be able to understand it in a better way. So for example, if I'm trying to roll a dice, right? If I'm trying to roll a dice. Now, so let's suppose if I'm trying to say that, okay, so there is a event A. Yeah, there is a event A. And in a event A, I'm trying to find out always a even number. So when I'm trying to roll out the particular dice, so as a event A, rolling an even number. So what could be the outcome? So outcome wise, I can get 2, I can get 4, or I can get 6 as an even number. And then there is a event B, and I'm saying that okay, so basically what is a chance, or like a rolling a odd number, rolling a odd number. So I can say that, okay, rolling a odd number is going to be 1, 3, and 5. So we can see over here that A and B are technically a mutually exclusive event. It simply means that there is no intersection between A and B. There is nothing common between A and B. So here, in that case, probability of this A and B, when A and B is mutually exclusive event, it's complete like a separate event, I can say, or it's not dependent upon the each other. So probability of this mutually exclusive event is going to be 0 at the end of the day. So this is something called as mutually exclusive event. Now, what is a meaning of independent event? Yeah. So what is the meaning of an independent event? So let's try to understand that particular part as well. Independent event. So again, independent event means one event should not depend upon the other one. That is the definition of the independent event. And based on that, we are going to find out the probability. So again, if there is a mutually exclusive event, in that case, probability is going to be 0. As simple as that. So if someone is going to ask me that what is the probability of event A and B? So it is going to be technically 0. Simple as that. Now, independent event, what is the meaning of independent event? So for example, we have an event A and we are trying to flip a coin. So here, first coin is head. Yeah, first coin is head. So let's suppose if I'm trying to flip 2 coins, 1 and 2, right? So we have 1 and 2 coins. So first coin I have flipped, and that is been captured by event A. So first coin is head. And if I'm going to like flip a second coin, and then second coin is tail. And we can say that both the events are independent. We are trying to flip 2 separate coins, by the way. Yeah. So both the independent event. So in that case, probability of A intersection B is going to be probability of A into probability of B. So if this is going to be the independent event. And again, so this is something that we try to understand. This is something that we try to learn with respect to a naive Bayes equation. So which I'm going to talk about in my upcoming lecture. So immediate upcoming lecture, I will be talking about that one. But yeah, so now we are able to understand that what is the meaning of a mutually exclusive event, and which is like a independent event. Independent event means 2 independent event. I can try to like do it simultaneously, simple. And mutually exclusive event means so some event which cannot happen simultaneously. So if I'm trying to roll a dice, either I will be able to get an even number, or either I will be able to get an odd number. So same time I can't get both the things, right? So cannot occur simultaneously. This is the definition of a mutually exclusive event. And when I'm talking about the independent event, 2 separate coin at the same point of a time, 2 person is trying to flip, and A and B is an independent one. So if someone is going to ask me that what is the probability of occurrence of A and B together, so this is the probability formula I will be able to apply. Simple, right? So with that, thank you so much everyone. Take care and see you again in my upcoming lecture.